Alright, today we're going to talk about the law of sines, and we're going to continue along using triangles and rules for triangles. This one does not have to be a right triangle. That's one of the things you're going to notice about the law of sines and the law of cosines that we'll talk about in 6.2. The triangles we're dealing with these does not have to be right triangles. Everything we've dealt with as far as triangles before, with your sine, cosine, all that stuff, the applications, it had to be with a right triangle. Now we're going to get away from that, and we've got some specialized laws using sine and cosine that does not have to be used on only a right triangle. Alright, an oblique triangle is a triangle that does not contain a right angle. Figure 6.1 shows that an oblique triangle has either 3 acute angles, this one, or 2 acute angles and 1 obtuse angle. You can never have more than 1 obtuse angle because we know all the angles inside of a triangle add up to give us 180. And with that, if we have one angle that's greater than 90, that means that the two other angles have to add together to give us a number that's less than 90, so there's no way either one of those could be greater than 90 in itself. So that's one of the rules we have. Now, notice that the angles are labeled A, B, and C, and the sides opposite each angle are labeled as A, B, and C respectively, lowercase here. So notice that side A, the same way we've looked at when we were talking about the right triangles, side A is always going to be opposite angle A, side B is always opposite angle B, and C is the same way. That becomes really important when we start looking at the way these things are, the laws are set up. Now, the relationship among the sides and angles of right triangles defined by trigonometric functions are not valid for oblique triangles. So we can't use the sine, the cosine, the tangent ratios because they are specifically for right triangles. Now, we must observe and develop new relationships in order to work with oblique triangles. Many relationships exist among the sides and angles in oblique triangles. One such relationship is called the law of sines, and this is the law of sines right here. If A, B, and C are the measures of the angles of a triangle, and A, B, and C, lowercase, are the lengths of the sides opposite these angles, then the ratio of A to sine A is equal to the ratio of side B to the sine of angle B, and that is also equal to the side C divided by the sine of angle C. So each one of these ratios must be equal. Well, what that also means is that this proportion holds true, or this proportion holds true, or the proportion of A and C holds true. So we can take this, and if we know some of them, we can solve for the others. Now, you can also flip each one of these over and put the law of sines in the numerator. A lot of times you're going to see me do it this way. That's just the way I've always done it. That's the way I'm more comfortable with it. But it doesn't matter. As long as you flip them all over, it still holds true. Now, you can't do side A over sine of A is equal to sine B over side B. You can't flip one of them. You've got to flip them all or it doesn't work. Now, I'm not going to go through this, but here's where the proof comes from, and it comes from actually breaking this thing down into two triangles and using the H here to draw one side or the other and all that stuff. Like I said, I'm not going to ask you about this or anything like that, but you are going to need to know how to find that. You can just drop an altitude here, and it's going to be a right angle to this side right here. So now you've got a right triangle here and a right triangle here you can deal with. Now, solving an oblique triangle is just like solving a regular right triangle. With the solving of triangles, remember, you didn't solve the triangle until you had all the sides and all the angles. So you've got to know 3 measurements for your sides and 3 measurements for your angles. So the law of sines can be used to solve a triangle in which one side and 2 angles are known. The 3 known measurements can be abbreviated using side angle angle or angle side angle. Now let's solve this triangle right here with angle A being 46 degrees, angle C being 63 degrees, and side C being 56 inches. All right, now I'm not going to write the whole thing out. Actually, yeah, I am. I'm going to write the whole thing out first. So you got sine of A over A equals the sine of B over side B equals the sine of C over side C. Now, I'm not going to use the whole thing at one time. Now, let's go through and we're going to talk about what we know. We know angle A, so I can do that part. We know angle C, so I've got that part. And I have side C, so I've got this part. So I know I'm going to want to use this one. And I've got part of this one, so I can solve for the A here for side A. So that's what I'm going to do. I'm going to use this and make a proportion. So when I do that, I'm going to have the sine, as I put my angles in, of 46 degrees over side A is equal to the sine of 63 degrees divided by side C, which is 56 inches. Now, when we do solve our proportion here, remember we're going to cross multiply. So we're going to have A times the sine of 63 degrees is equal to 56 times the sine of 46 degrees. Now I can find all this right here, and remember I'm looking for A, so I'm going to end up dividing both sides by the sine of 63 degrees. So when these cancel out, I'm going to have just A is equal to 56 times the sine of 46 degrees divided by the sine of 63 degrees. All right, now I'm going to find that to the nearest tenth. All right, and when I do that, I'm going to get 45.2 inches. So that is side A, 45.2 inches. All right, now, once we have this angle and this angle, we already had that to begin with, we can go ahead and find this angle, right? Because we know 46 plus 63 plus angle B must equal 180 degrees. So I know the measurement of angle B plus 63 degrees plus 46 degrees equals 180 degrees. So when I go and I break that down, I can solve for B. And I'm going to get that measure of angle B equals 71. Now, all you're going to do here is you're going to take and you're going to put the 71 in, and you're going to use these two right here. Now, the question may be asked, or you may be thinking, okay, well, I've got both these parts right here now. Why don't I use sine A over A and sine B over B and solve for B that way? You can do that. There's only one problem, and one reason why I'm going to instruct you to go back and use the sine C over C. The sine C and the C here are given information. That's information that you had from the beginning that was in the problem. What do we know about this A right here that you would put in? you solved for it. So what's going to happen is if you made a mistake and found A wrong, you're now going to take that error and you're going to introduce it into finding side B, and you're going to have two things wrong. Whereas if you solve this using sine C over C both times and you make a mistake and get A wrong, you're not guaranteed that you're going to get B wrong. You might actually get it correct. So it's a good idea to always go back to given information if at all possible. Don't take the chance of making a mistake and it multiplying all the way through your problem. Alright, so let's go ahead and set that up. So we're going to do sine B over B, and I'm going to change colors so they don't get quite as mixed up here. So you're going to have the sine of 71 degrees over side B is equal to the sine of 63 degrees over 56. Once again, I'm just going to cross multiply. So you get B times the sine of 63 is equal to 56 times the sine of 71. And when I divide both sides by the sine of 63, all right, and for B, I'm going to get the angle, or sorry, the length of 59.4. And once again, that's in inches. So I know that this is 45.2 inches, this is 56 inches given, and this is 59.4 inches. Now, one way that you can use this, or that you can use an idea that you should know from geometry, I'm going to refresh your memory on it. What do we know about the longest side in a triangle? Well, it's always going to be opposite the largest side. If you get a situation where this one right here was less than this one, you would know you've done something wrong. The longest side will always be opposite the largest angle, and the middle side will always be opposite the middle angle, and the smallest side will always be opposite the smallest angle, and the reciprocal of those. The smallest angle will always be opposite the smallest side. So you can figure all those out. It's not going to be something that you can look at and say, oh, I know, I'm guaranteed that's right. But it's a thing that if you make a mistake, it might help you catch one of those mistakes before you continue on. Alright, so then of course, all we have to do is we have to list everything out. When you solve one of these guys, I want you to list all the information that you found out. I need to be able to follow your work, and I need to be able to find out where you solved each part, and I need to see all those final parts. So here we calculated or found out that the measure of angle B was 71 degrees, and side A was 45.2 inches, and side B was 59.4 inches. So when you label that and show your work, you get full credit. But I do need to see the work for all of it. Guys, don't do anything in your head. I want on tests, I want the work shown. Alright, so triangle ABC has A is 50, C is 35.5, and B is 76. And we're going to round our answers to the nearest 10. Alright, so once again, what you want to look for is you want to look for one of two things. You want to look for A, do we have, first you want to look for, do we have a set of angle and side with the same letter? In this case we don't. We have A is 50 degrees, but we don't know side A. We know C is 35.5, but we don't know what C is, side C is. And we know what the side B is, but we don't know what angle B is, but we can solve it. Because we got 50 degrees here, 33.5 degrees here, we know if we subtract those two angles right there from 180, we're going to find out what angle B is. So the measure of angle B equals 180 minus 33.5 minus 50. So that's going to be 83.5, and that's going to end up with 96.5. So we know that this angle is 96.5. Now we have a set, and yes, we did have to solve it, but hopefully you're not going to get that subtraction problem wrong. If you do, I mean, everything that you're going to find from here on down is based off of that. So you got to make sure you get that angle. If you don't get that angle, you've kind of messed up the whole problem. But now we have a set of angle and side that we can use for solving the other two parts. So I know that the sine of 96.5 over 76 is equal to, which one do you want to solve first? It doesn't matter. I'm going to go ahead and solve the side A, and it's equal to sine of 50 degrees over A. So of course then I'm going to cross multiply. A times the sine of 96.5 is equal to 76 times the sine of 50. And then we'll divide both sides by the sine of 96.5 to find out that A is equal to 58.6. All right, now you'll just do exactly the same thing. You'll still use this one, and you're going to use it to solve what side C is. So we would have the sine of 96.5 divided by 76 is equal to the sine of 33.5 degrees, I keep forgetting my degrees, divided by side C. Cross multiply again. So C times the sine of 96.5 is equal to 75. That's supposed to be 76, sorry. 76 times the sine of 33.5 degrees. Then of course we'll divide both sides by 96.5 to find out what C is. And for that I get 42.2. Alright, so A is 58.6, C is 42.2. Alright, so once again, just do your little quick check deal here. What's my largest angle? 96.5. Is my largest side across from it? Yep. What's my next largest angle? 50 degrees. Is my next largest side across from it? 56.8 is greater than 42.2, so yes. And smallest and smallest, so it does work. Now, once again, that's not 100% checking that it's going to be correct, but if that doesn't fit, then you know something's wrong. Now, we have a situation called the ambiguous case, and we're going to talk about it in class because I want to be able to see that you understand it. And all it is we actually end up with a situation where we might have a triangle, we might not have a triangle, and there's even a case where we might have two triangles. But we'll talk about that situation in class, and it is not one of the ones we've talked about. Remember, we talked about the side angle and the angle side angle. This is the side angle. And that case right there, we can only use the law of sines for it, but we have to be real particular about it because it can give us a situation where, as I said, we don't have a triangle, we have one triangle, or there might be two possible triangles, and we don't have enough information to differentiate between the two to tell which one it's actually talking about. But like I said, we'll talk about that in class. Don't worry so much about that. It's not that big a deal. It's a lot more work, but it's nothing different than what you've already done.